joined, and YouTube live students, good evening. How are you, students? Davangere students, let me know. And is there any test going on so that the students haven't joined? Good evening, Davangere students. Okay, Ballari students, good evening. Is it two section? Davangere, is there any A and B section? Two different sections? Yeah, hello. Can you hear me now? Okay, Ballari students, good evening. Okay, let me know. We'll be starting our session at least 1 minute later. But in the meantime, let me know, is my audio is clearly audible or not? Is my screen visible or not? Since there is no poll, okay? Since there is no poll, let us go through the, let's say, message authentication, okay, from you guys. Let me know. Sweetie, good evening. Okay, Sweetie, I had to send you advanced papers, right? Yes. Sweetie, thank you. I had to send you advance paper, right? Sorry, I was on a leave, okay? So I'll be sending you soon. Okay. Okay, there is a lot of disturbance. Is there any lot of disturbance? Let me know. Okay, just a second. What type of disturbance are you getting? Can you just, Sweetie, let me know, and others let me know. Is there any other disturbance? Let's say Davangere students, let me know. Let me know, students. Then we'll be starting our session. Sweetie, let me know. Is there any audio issues? Any disturbance that is that you are getting through my voice? And in the meantime, let me try to let's say check it. Good evening, Suman. So I'm just checking my audio. Okay, sweet. Is there any delay? So much delay in my voice? Is there any delay? Since there is no poll, so I'm not that sure ki what is the issue. Okay. Yes, okay. Ballari students, there is a delay. Yeah, hello. Can you hear me now? Is everything good? Let me know now. Is there any delay in my voice? Then we'll start our session. Okay. Is there any delay? Let me know. Is there any delay? Okay, sweetie, you're saying okay, cool. There is no delay. Good. Others, Ballari students, if there any issue, let me know. Okay. Otherwise, you can just restart your session. Let me know once. Okay. Oh, namaste, Chitradurga students. Okay. Okay. So yeah, so anyways, it's already time. So students, welcome back to our session. My name is what? My name is Samanmeet. I'm a physics faculty. Yes. So how was yesterday's session? So did you get to know how to solve numerical problems and all? Let me know, students. Were you able to solve the numerical problems? Was it easy solving numerical problems? If it was not easy, then yeah, then my concept was not clear. If that is the case, let me know. Sweetie, Davangere AB students, Uttara Kannada students, let me know. Ballari students, Vemula, Ballari students, let me know is there an issue now, okay? Let me know. Yes or no? Students, what we are going to do is, anyways, we are starting the session. We are, okay, thank you, Sweetie. So we are what quickly recalling what yesterday's session, what you have done, okay? Not yesterday's session basically. Today we'll be talking about lots of numericals, okay? So for that reason, we'll quickly go what and all we know, what are the formulas we know, or what are the concepts we know, okay? Then students, there is this block and block diagram. Basically, what this talks about is two blocks upon each other, which is kept on a surface. And let's say there is a force on this, or there is a force on this. Now you need to find the what the maximum force, or let's say the acceleration, the maximum acceleration. So based on this, there are certain numericals. Then what we will be talking about numericals, students. Let me know. Is it clear, students? Is it clear? Is it clear till now? Yes, very good. It's very good. Ballari Davangere students, let me know, and Uttarakhand students also, please let me know. Now, talking about what we have studied in the last one. See, we have talked on numerous things. Okay, starting from what? Newton's laws of motion. What? Newton's all three like laws of motion, three laws. Newton's three laws. Yes, in that we came to know lot of things. Yes or no? The change in momentum is equal to the force. The force is proportional to the change in momentum. We also saw that. We saw that F is equal to M into A, where we saw that what when M is kept constant, yes, when the mass is kept constant. We saw that. And later on, we saw that what friction, we talked about friction. In that friction, we were talking about what three types of friction. One is static, one is what? One is limiting friction, static friction, limiting friction, and the another is kinetic friction. Yes, and you know that the static friction is a variable friction. Variable friction. It depends on what? The applied force. It depends on what? The applied force. Yes. Then limiting friction is the maximum value of the static friction. Fs max is basically equal to what? Limiting friction. Basically, it is telling what? See, when you apply a force, when you apply force which is greater than what? Which is greater than the what? The static friction, Fs max, or the limiting friction, दोनों same है, then what will happen? The object will move. Yes or no? Yes or no, students? Let me know. And the kinetic friction is what? Fk, we used to say Fk, this we used to say what? F limiting. This is what is basically when there is a relative motion. When there is a relative motion. And we know that we have the formula Fk. See, we have a lot of formulas. One is what? One is F. S equal to what? The applied force basically. Applied force. And you know that F limiting is equal to what? Mu S into N. Yes or no? Where N is what? N is the normal force that is acting. Yes or no? Where it is equal to M into G. So see, over here, as I said, see, you know that this normal and this weight will cancel out. So can I write N is equal to M into G? Yes or no? So please remember this, students. This is very important. Then students, what did we talk about? Then you know that Fk is equal to what? Mu k into N, and where mu k is what? Coefficient of kinetic friction was what? Kinetic friction. So students, do you remember all of these things? Do you remember all of these things? Yes, yes or no? Let me know in the chat. Yes or no? Yes or no, students? Let me know. Yes, good, good. Okay. If that is the case, students, okay, good. See, in the last class, I gave this problem as a homework question. So did you guys do it? Or I'll be giving again 3 minutes of time to solve this. Solve this, try to solve this problem, students, and let me know what is what. What is the basically they're asking for what? What is the acceleration on the block and trolley system? So I want what? The acceleration. And also I want the tension value. So what is tension? Let me know, students. And I'm giving you 3 minutes of time. See the diagram. I will explain the diagram later. Okay. Completely, I'll explain it. Don't worry. Sweetie, did you do the homework? Let me know in the chat. Now, here is the 3 minutes of time that I'm giving to you. Please try to solve it. Okay, Sweetie. Okay. Do one thing, Sweetie. Try solving this one. Okay. Try here. Hopefully, you'll be getting answer here. Okay. Try solving it here. So here's the time, students. The 3 minutes have started. Please let me know. Davangere AB students, you should solve it. Ballari students also. Ballari students, is there any problem now in my audio? Chitradurga students, check your answer once. Recheck your answer. Others, the time is running. Please let me know. And YouTube students, please let me know. What is the answer for it? Okay. Chitradurga students, do you think the acceleration will be different? Do you think the acceleration will be different? So that is my question. Last 10 seconds. Okay, okay. So check your answer then. Okay, student, time's up. So should I solve it? Let me know. Should I solve it? Let me know in the chat. Should I start solving it? Okay, see, over here, there are certain information that is given. Okay, one thing is, see, what we want. What we want is acceleration, but I want tension also. Okay, now, so basically they're asking acceleration of the block and trolley system. Okay, they're asking the total acceleration of this system. Now, they said that if the coefficient of kinetic friction between the trolley and the surface is 0.04. So basically they're telling what? Let's say you have this diagram over here, okay? This one, you have this system and you have this system. Now students, let me know. See, over here, there is a block of mass 3 kgs and there is a 30 Newton, what? That is weight, that is the weight that is acting basically. If it is acting downwards, students, won't there be a force that is, let's say, acceleration acting along this direction? See, in the diagram also, they have given a information that is Fk. they told that the kinetic friction is acting along what Fk in this direction. So students, can I say the information that they have given, what mu k is what 0.04, then can I write Fk is equal to mu k into n, what, for this system, yes or no, for this system. And you know that for this, can I write it as what, there is a weight that is acting, that is what students, 20 g, and there is a normal force that is acting n. So can I take n equal to 20 g, yes or no students? So let me take g to be 10 meter per second square. Now students, can I write Fk equal to what is mu k? 0.04, 0.04 into n is what, 20, 20 into 10. So will it be Fk be 8 Newton? Yes or no students? Let me know in the chat. Fk is 8 Newton. Basically, there is a force that is acting along this direction is what? 0. Sorry, this is 8 Newton. Yes? Is it clear till now? The first step is clear. Let me know, sweetie. समझ आ रहा है? Chitradurga students, let me know. Uttarakhand students, let me know. Yes, very good. Now, अभी देखो इस diagram में they told that if it is moving in this direction, there's a tension along this, along over here, and there's a tension along this direction. Now, students, can I apply this formula? See, over here, there is what? There is a Fk that is acting along this direction. See, you know that if acceleration is along this direction, so can I write t minus 8 equal to m into a. In the chat, can you hear me, students? Let me know in the chat. Okay, there are I guess internet is very unstable. Just a second, students. So students, can you hear me very, very clearly, or is there any disturbance? Let's say there's a delay and all. Students, let me know in the chat. Okay, not clear. Okay, just a second. For 1 second, then 1 minute. Okay, students. Okay, got it. Okay, I got to know where the mistake is. It should be 10 per second square. Okay, it should be 10 meter per second square. Is it good? Please solve it now. That was the clear or not? So there is a power issue. Please let me know. Okay, voice is breaking a lot, Krishna. Okay, sweetie. Just a second. Okay, students, is it clear now? Is my audio clear? It is still breaking. Let me know. Okay, Chitradurga students, good. Okay, Suman, clear. Thank you. Others, let me know. Others, let me know in the chat. Others? Sweetie? Clear? Okay, good. Thank you. Clear, Sweetie. Okay, good, good. Okay, thank you. Now, students, over here, see. Okay, there's a mistake. You should have taken what it to be g equal to 10 meter per second square. Okay. Okay, Sweetie, let's check. Let's check. Okay. Now, can see I told you that you see for this system, can I write? See, since acceleration is along this direction, can I write t minus 8 equal to m into a, and can I write t minus 8 equal to what is mass? Mass is 20 and a is the acceleration. So is a good student still now. So let it be this first equation. Now for this quantity, what is that quantity for this system? That is what, let's say that is the T Newton that is acting, there is a tension that is acting, and you know that the acceleration is along this direction. So can I write 30 Newton minus T equal to the mass is what? The mass is 3 kg basically. This is 3 kg. So 30 Newton minus T equal to what, students? This is 30 Newton minus T equal to 3 into A. Yes or no? Let me know, students. Just a second. Yeah. I was mute. I was checking the power. Okay. Okay. Now this is the second equation. The first equation was t minus. The first equation was t minus 8. 8 equal to t minus 8 equal to equal to 20a, equal to 20a. Now the second equation was 30 minus t equal to 3a. So students, can I add these two equations? Can I add these two? If I add these two equations, students, what will I get? Tt get cancels out. 30 minus 8 is what? 22. 22 equal to 22 equal to what? 23a. Now acceleration is equal to what? 22 divided by 23 meter per second square. Did you get it, students? Let me know. Which equation you're asking for? Which equation are you asking for? For the second equation or for the first equation? Let me know. Down get students. For the first equation or for the second equation? See, for the first equation, let's say you know that the what acceleration is along this direction. If the acceleration is along this direction, see, we take tension to be positive. Yes or no? We take the tension to be positive. And if the acceleration is along this direction, so will I take 30 Newton to be positive? I'll take 30 Newton to be positive and T to be negative. Yes or no? T to be negative. Because why? Because the acceleration is along the downward direction. Yes, downward students, let me know. Since the acceleration is along this direction, see over here, there was a system basically, and there was a trolley that was moving, and the trolley is moving along this direction. There is acceleration, and the body is moving along this direction. There is this acceleration. Yes, let me know. Downgrade students, let me know. And others, Krishna, Sweetie, is it clear? Davangere students, Davangere B students, let me know the is it clear or not? Good, good. Krishna, very good. Others, Sweetie, Suman, okay, good, very good. Uttara Kannada students, and okay, Bagal students hasn't joined. Okay, Tumku students, let me know. Okay, good, good, very good. Now, so as I said, we got what acceleration, and I want now what tension. So can I use the first equation And can I write t minus 8 equal to 2 into a? And will I get t minus 8 equal to 2 into 22 by 23? Yes. And what, students? T equal to 44 by 23 plus 8. Now this will be your tension, students. Did you get it? And this will be the Newton. So you can solve this. You can solve this and you will get the tension value. Is it good? Let me know. Or you can use this equation also. If I use 30 minus t equal to 3 into 22 by 23. Yes. Now I'll get what? T equal to 30 minus 66 by 23. And there will be a tension value. There will be a tension value over here. Is it good? And you can solve this also. Yes. You can use a calculator or you can solve if you know how to solve it. Yes. So divide it by 23. Is it good, students? Let me know. Yes. Others. Let me know in the chat. And YouTube students, let me know. Is everything clear? Is it visible or not? Good. Very good. Very nice. Now, oh, is it 20A? Okay, good. Just a second. Okay, it's 20A. Sorry, this is 20. This is 20. Then that is 20 is 440 basically. 440 plus 8. Okay, good. Yes, very good, very good. Very nice. Now, if that is the case, students, now here is a problem. Okay, now they're saying calculate. Here's the second question. They're saying calculate the tension in the string connecting the wall and the block if what the force is what 20 Newton and the force is 60 Newton. Now, students, I'll give you the diagram of the block and I'll give the other information also. So basically, they're saying there is a wall and there is a block involved. There is a block that is involved. Okay, there is a block that is involved, and that block is 20 kg. And they're saying that they're pulling this block with the force F. The first time equal to 20 Newton, and for the second time what 60 Newton. Okay, now for both the cases you have to find the tension value. You have to find the tension value. Here other information are the mu s value is 0.30 and mu k value is 0.25. 0.25. Now students, I'm giving you again 3 minutes of time to solve this. Please let me know. Okay, please solve this. Okay. So see over here, don't take the force value together. This is two different cases. That is what the first case and the second case. Okay. So there is a wall and there is a mass of 20 kg. They're trying to put a force. Now you need to find the tension. What will there be a tension, or what if there is a tension? What is a tension value? Okay. So yeah, 3 minutes of time. The timer has started. Please let me know, students. And yeah, I can't on the video. So okay, the power has come up. So wait for. And yeah, please answer this question. Okay, Davangere students, first check your answer. Check your answer once. There is a trick to it. There is a very interesting trick to it. Okay, I'll tell you the trick. everything. See, information is given. Mu s value is given, mu k value. That is the case. Why they are giving mu k and mu s value? There should be some reason, right? There should be some reason. So check the reason and let me know the answer. Okay, Chitradurga students, check your answer. I'll start to set up things, okay? Okay, sorry. Sweetie, are you trying? Krishna, are you trying? Let me know. Suman, Davangere, AB students, Uttarakhand students, are you trying or not? And Uttarakhand students are not replying today. So what is the case? What happened? Very good, Suman. Good, good. Okay, time's up, time's up. That is the case, students. You need to, what? You need to see here. Okay. Over here, they said that, see, first thing is, they said that they're trying to what? Put a force first initially, what? F is equal to 20 Newton. Now, what is this? Basically the applied force. Basically the applied force. They're applying a force. Okay. Now, students, there are other information that is given. That is what mu s value is 0.30 and mu k value is what? 0.25. Now, students, I want to ask you, when will the body move? If the applied force is greater than F limiting friction, then the body will move, yes or no? Yes or no, students? Let me know. Okay, good, good. If that is the case, first thing we need to do is, we need to find what is F limiting. What is F limiting? See, for this body, can I write this as the normal force and this as the weight that is acting? That is what? M into G. And weight is what? 20 G. Let me take G to be what? 10 meter per second square. Okay. Now, if that is the case, students, can I write what is mu s? So mu s into n and F limiting equal to what? 0.30 into 20 into G is 10. So will it be 60 Newton? F limiting is 60 Newton, yes or no? Now, students, very good. Down here, students. Now, see, there are two cases. What F applied is 20 Newton and what F applied is 60 Newton. Now, students, I want to ask you, if both the cases, for both the cases, for let's say 20 Newton, will there be any movement? Will there be any movement? Yes or no? No. If there is no movement, if there is no forward movement, students, will there be tension? There will be what? No tension. Yes or no? So for that case, tension equal to 0, students. Did you get it now? So if that is the case, students, you need to write what? T equal to 0. This is your answer. Now, for the second case, applied is equal to 60 Newton. Now it is a what? It hasn't overcome the limiting force, that is the maximum limiting force. It is just equal to what? It will start. It is a verge. It has a verge to what? Start the motion. If that is the case, students, will there be tension? For this also case, there will be no tension because there is no movement. There is no motion basically. Did you get it, students? Let me know. Yes. Let me know in the chat, students. Let me know. So for both the cases, t equal to 0. Because why? Because the applied force, yeah, then there will be tension, the undergraduate students. Then of course there will be tension. Because applied force is what? Is less than the limiting what? Friction. So this will be your answer. Yes. Sweetie, is there any doubt? Did you get it or not? Okay. Others, if you have got any doubt, okay, good. If you got any doubt, let me know. Let me know in the chat. Amrita, okay. Okay, Amrita, very good, very good. Okay. So whoever is present in YouTube, very good, Amrita. Others who is present, let me know through the chat. Who is it? Let me know your names. Very good. Amrita, okay, what is the answer? Very good. Now, if that is the case, students, then we are going to jump into a concept called block and block diagram. Okay. What is this block and block diagram? This is very easy. Okay. Now, this block and block diagram basically says that, let's say, what? See, block and block. So there are two blocks. So there are two blocks and it is kept on a surface. Okay. Now, students, you know that if I'm trying to pull this block, let's say this is block number 2 and block number 1. If I'm trying to pull this block F with the force F, students, what will happen? Can you guess what are the scenarios that can happen? Let's say, first thing, if I pull block one slowly, what will happen? If I pull the block slowly, what will happen? See, over here, can I say the upper block will also, if I pull block 2 slowly, what will happen? Can I say the upper block will also move along block 2? Yes. Can I say this? Yes, very good. Now, if that is the case, if second scenario, if I pull using a lot of force, what will happen? मैंने ಎಂತ ಮಾಡಿದೆ ಇದನ್ನು मैंने क्या किया, इस जो नीचे वाला है ना उसको बहुत जोर से पुल किया, तो क्या हो सकता है? अगर मान लो 2 ब्लॉक रखा है, ठीक है, ऐसा रखा है और मैंने इसे पूरा पुल किया, तो क्या हो सकता है? Yes. Okay. Or you can say, yes, can you say the first block will fall down? Can I say this, students? So there are two scenarios. Whenever you apply a force on a block, there are two scenarios that comes into picture. One thing is that both the blocks will move with the same acceleration. Can I say? And also, you know that what other case is what one of the blocks might fall down as the upper block. Basically, the upper block, this upper block will what? Fall down. Now, students, you know that for both the surfaces, there are certain what coefficient of friction, that is mu1 and mu2 and mu1. Yes or no, students? Okay. Now, students, basically what is happening over here is you need to guess. Okay. You know that, okay, let's say, okay, if this block M2 is moving, you know that what will happen? Dekho, agar main if you are sitting in the second block, now we are applying a force on the first block. Yes or no? Now, students, if the second block is moving, it is seeing the first block, it is moving what? Backwards. Now, will the block allow it to move? No, right? See, if this block is moving forward, if it is moving forward, then this block will move backward. Now, if that is the case, students, this block 2 won't allow the block 1 to move backwards. So if that is the case, can I say this block 2 will apply a friction force? Block 2 will apply what force? Friction force. Yes or no? Yes. Yes or no, students? Let me know. Yes or no? Yes. Very good. Very good. Yes. Okay. Now, students, see over here, we need to see what is the limiting friction is. Okay. Now, basically in question, there will be asking is find the maximum force that is required. Okay. They will be asking a question like maximum force is required. Now, students, here you need to keep in your mind is what the first thing you need to take care is what students, what is happening? What make sure you identify whether blocks will move what first thing together or not. Okay. See, I just said, see, if I'm trying to pull the block with lesser force, then can I say lesser force? Can I say in this case, the acceleration is same? Acceleration is same. Yes or no? सही है, सही बात है. Now, the second case, see, if I'm what pulling with lot of force, so basically what is happening? There is a difference in the acceleration. There's a difference in acceleration. है कि नहीं? इसी की वजह से वो गिर रहा है ना? Yes or no? Yes or no, students? Let me know. Is it clear till now? ठीक है? Yes, very good. हाँ. तो आपको जब सॉल्व करना है ना, द फर्स्ट स्टेप इज टू आइडेंटिफाई वेदर वो साथ में जा रहे या क्या और नॉट. ठीक है, वो अगर साथ में जा रहे हैं तो एक्सेलरेशन सेम है, अगर साथ में नहीं जा रहे तो क्या है कि एक्सेलरेशन डिफरेंट है. ये बहुत हेल्प करेगा. लेकिन ये हेल्प कैसे करेगा? सॉल्व प्रॉब्लम करने के, अगर इफ यू वांट टू सॉल्व द प्रॉब्लम, हाउ इट विल हेल्प यू. नाउ स्टूडेंट्स, see over here, you know that there will be a what, there will be a, let's say, see over here there is a block. Okay, अगर मान लो मैंने इस पे फोर्स लगाया, ठीक है, इस पे फोर्स लगाया और आपको पता है कि ये जो ब्लॉक है, सेकंड ब्लॉक है, वो पीछे जाएगा. लेकिन पीछे जाने के लिए वो क्या करेगा? ये फर्स्ट ब्लॉक विल अप्लाई फोर्स. यस और नो स्टूडेंट्स? यस. नाउ स्टूडेंट्स, मैंने ये बताया कि अगर मान लो मैंने ज्यादा फोर्स लगाया तो okay, तुमको students just think, if I'm applying a force over here to the first block, then there are two scenarios. If I'm applying a lesser force, then I told you if lesser force, then what did I tell you? The blocks will move together. मैंने ये बोला. yes or no? अगर मैंने ज्यादा, let's say तुमको students ना तुम force ही दे दिया, so what more force, if that is the case, then the second block will fall down. Yes or no? Will fall down. Yes. Good students, let me know these two cases. Now, if that is the case, students, can I say from both this there is a limit? Let's say that is what the maximum force. देखो, अगर maximum force से नीचे है, then what, the blocks will move together. अगर maximum force is ज़्यादा है, if maximum force is ज़्यादा है, what will happen? If the applying force is greater than F max, then what will happen? The body will fall down, the second block will fall down. If the applied force is less than F max, then what will happen? What? The acceleration is same. Then the acceleration is same. Can I say this? Now, students, if that is the case, then we need to find the maximum force that is in. Did you get it now? Did you get the gist of our problem now? How do you solve it? How to approach the problem? Yes? Let me know. Yes or no? So basically what? See, till F max, the what? The blocks will move together. Hey, ki nahi? अगर F max पे लगाया ना फिर भी ब्लॉक सेम होगा ना, they will move with the same acceleration, yes or no? Students, let me know. Now here there are certain, in order to solve problem, there are certain steps you need to, what steps you need to carry on. The first step, okay, the first step is what is the first step? Find f limiting on both surface. Okay, for both surface, what is happening over here? Let's say students, over here there are two blocks, there are two blocks. Okay, now this is m2. Let me take this m1 and let me take this m1. Okay, oh sorry, m2. Now students, let me ask you, see, you know that there is a friction force acting over here, there is a friction force acting over here, yes or no? Yes or no, students? If I'm applying a force along this direction for this m1, you know that there is a friction force over here also, yes or no? Now students, how to find friction force? You know that F is equal to what? The limiting force basically. What is it? F limiting is what? Mu S into N, yes or no? For the first mass m2, you know that, okay, this is the normal force, and you know that there'll be a what? There'll be a mass that is acting, weight that is acting, m2g. So can I write normal equal to m2 into g? Can I write it, students? And let me take this as what? N2, normal force on the body m2. So can I write F limiting equal to, don't worry, we will be able to clear this doubt very clearly when we solve problem. Okay, when we solve one problem, don't worry. So F limiting equal to mu S into m2g. Can I write this? For what? For m2 mass. Can I write, students? Let me know. Similarly, you know that there is a friction acting over here. Yes or no? Yes or no, students? Yes or no? Now, for this m2 mass, you know that the total mass would be this mass, yes or no? Now, for this case, you know there is a weight that is acting, that is what? M2 plus M1 into G. And there's a normal that is acting, that is N1. So can I write F limiting equal to what? Mu S into M2 plus M1 into G. Yes? Yes or no? These two cases, students, you need to remember this, okay? These two cases, you need to remember this, okay? What is the first step? Find F limiting on both the surface. What? Find F limiting on both the surface. Yes? Now, coming into what? The second step. The second step. Search that block, okay, which has only frictional force, now students, अगर ये दोनों ब्लॉक है, let's say this is m1 and this is m2, and if I'm playing a force F, let me know, students, for which block there is only friction force. कौन सी ब्लॉक है जिसमें सिर्फ फ्रिक्शनल फोर्स अप्लाई होगा? किस ब्लॉक के लिए? लेट मी नो. दिस इज द फोर्स अप्लाइड m2 के लिए ना. वेरी गुड. m2 के लिए ना. m2 के लिए yes or no? yes or no, students? Because over here see, अगर m1 आगे जा रहा है वो देखेगा m2 को और m2 को बोलेगा कि पीछे क्यों जा रहा है. yes or no? अगर पीछे जा रहा है then this is a what? F limiting force that is acting. yes or no? So for m2 there is only what? Frictional force. There is only frictional force. Yes? Yes or no, students? बड़े स्टूडेंट m1 के लिए कैसे होगा? m1 ही ಆಗ್ತದೆ. m1 ಗೆ ಒಂದು F external ಉಂಟಲ್ಲ, there's a applying force. ಇಲ್ಲಿ ನಾನೆಂತ ಹೇಳಿದ್ದು, search the block which has only frictional force. Which is that block? That block is what? m2. m2 is right. Yes or no? Let me know. Amrita, let me know. Others, let me know. Yes or no? Very good. Very good. Now, students, can I say, see, agar मैंने ऐसा, see, I told you that if this is the block and this is the second block, you know that there is a frictional force that is being applied over here. Okay, it is the limiting force. So can I tell students, or can I say something like this? This is the maximum force that will be applied, on on block 2, on block 2. Yes or no? है कि नहीं? देखो, ಇಲ್ಲಿ ಒಂದು force apply ಮಾಡ್ತಿದೆ ಹೌದು, but the limiting force is basically acting due to the movement of m1. But can I say this will be the maximum force that will be applied on block 2? Yes or no? Limiting, I can't apply a force which is more than limiting, because if I apply more than limiting, then this block will fall down. Yes or no? So can I say this is the what? The maximum value. F limiting is the what? The maximum force. Yes or no, students? Let me know. If there are two blocks and if I'm applying a force on one block, then there is what? The friction that is acting. Now, this friction will be what? The maximum force. Yes, good. I'll draw. Simple, students. See, over here, if this is M2, you know that this, if I'm applying a force on M1, you know that this M2 will go backwards. Then there'll be a friction force that will be acting, Fk, and this is weight that is acting, M2g, and there is a normal force that is acting. And I told you, students, if that is the case, this is the what? The maximum force. Yes or no? Let me know. Yes or no? If that is the case, can I tell you that the acceleration will be the maximum acceleration, will be the max acceleration that will be getting. Yes or no? See, M2 के लिए जो F limiting है वही maximum है. Okay. तुमको students, just a second. See, so that is what? If that is the case, students, the acceleration is what? Is the maximum acceleration. अगर जो acceleration ज़्यादा है ना, देखो, if that is the case, can I say, see, देखो, इसके लिए क्या एक acceleration आ गया. अगर this acceleration of A2 is less than, if let's say for example A1, जो भी इसका acceleration आ गया, A1 is equal to A2, then the body will move together. or can I say A1 अगर less than A2 भी आ गया ना, फिर भी same जाएगा ना. Okay, sorry. अगर A2 भी, if A1 is less than A2, फिर भी क्या जाएगा, फिर भी दोनों एक साथ जाएंगे ना. They will move together. Yes or no? Yes or no, students? See, if M2 is moving with the acceleration what less than M2, which is the what maximum acceleration that is it is getting, due to what? Due to acceleration, sorry, due to friction, my bad. See, M2 is moving with the force. I am applying a force, and you know that due to that there is a for M2 there is a frictional force, and I told you that that will be the maximum force that will be applied. Yes, if that is the maximum force, you know that that is the, from that you get acceleration, and that acceleration will be maximum. Now, here you know that M1 will be what? Moving with the acceleration. Now, students, if M1's acceleration is equal to M2's acceleration, now if that is the case, if both are moving together with the same acceleration, then what? Then what? The body won't fall. Yes or no? Similarly, if this M2's acceleration is less than M2, what? M1's acceleration is less than M2. If this is moving slowly than this one, then also it will move together. Yes or no? For the both the cases, it will what? Move together. Yes. Yes or no, students? Now, talking about FBD of M1, you know that there's what? M1, and it is moving with the velocity what? With the force F. Then there will be a friction force that is acting what? F, due to the surface. And also, students, you know that see, if M1 is moving along this direction, M2 will tell that don't move. Yes or no? So there will be a what? There will be a limiting friction that will be acting. Yes or no, students? Let me know. है कि नहीं? एक limiting friction भी होगा ना, due to what? Due to the body what? M2. Did you get it, students? Let me know. Yes or no? देखो ये कॉन्सेप्ट थोड़ा ट्रिकी है, समझाना भी बहुत ट्रिकी है, बट आई एम ट्राइंग माय बेस्ट. ओके, प्लीज लेट मी नो. ओके, others लेट मी नो. ये थोड़ा ट्रिकी है, ठीक है, बड़ा स्टूडेंट्स गुड. अमृता लेट मी नो. वेरी गुड. Okay, Ballari students. Okay, see, don't worry. Okay, Ballari students, let's do one thing. Let's do one thing, Ballari students. Let's solve a problem. Okay, let's solve a problem. Okay, see, over here, we'll be solving the problem tomorrow's class. Okay, don't worry. See, I'll explain again. Don't worry. Now, the third step is for this. For the third step is, see, now you got what? The acceleration, the maximum acceleration. Due to what? Due to the what maximum force? Yes or no? Now, students, use the A max in the other block. Use the maximum acceleration in the other block and find F max for together motion. Okay, X max for the together motion. Yes or no? Okay, students, is it good? So what are the steps? What are the steps? Find F limiting on both the surface. What? Find the frictional force for both the surface. Next, what? Search the block which has only frictional force. Search the what block which has the what? Which has only frictional force. Then try to find the acceleration, that is the maximum acceleration. Okay. Now, and what you do? The last case is what? Use the A max in the other and find the F max for the together motion. Okay. Did you get it now, students? Okay. Now, students, this is for JNV Ballari students. What I'm saying is, let's say there are two blocks. Okay. Question nalli enta kottidare andre eradu block kottidare. Okay. The question will say that find F max, find X max. Okay. Now there are two blocks. What are the two blocks? That is M1 and M2. Okay. Here they are asking for F max. Now first step is find F limiting for both the surface. For both the surface. Now they told that the force is applied over here. Now students, how can I check? How can I do it? Let's say for the block M2, will there be any friction that will be acting along this direction? See, agar M1 is moving along this direction, this M2 will what? Move backwards. Yes or no? If that is the case, M1 will apply a friction force F. Yes or no? This friction force. And you know that there's a weight acting M into G and there's a normal force acting. Yes or no? So can I say that this frictional force is basically what? This friction is what? Limiting force. Yes or no? So this is limiting force, which is equal to what? Mu S into N. And you know that from this, N equal to what? M into G. And I get F limiting for the what? M2 mass is equal to what? Mu S M into G. Yes? Is it clear? Is the first step clear? Yes? Now, similarly, you need to draw for what? M2 mass. Now you know that over here the total mass would be what? For this M1, the total mass would be M1 plus M2. Yes or no? And you know that what? There's a friction force that will be acting along this direction, because the force is acting along this direction. There is a limiting force. So F limiting equal to what? M1 plus M2 into what? Into G and into mu S. Yes or no? And this will be the case because what? Because we have F limiting equal to mu S into N. Let me know, students. Others, let me know. Till now it is clear. The steps I'm repeating again. Ballari students, let me know. Others? Okay. Now, second step is, they're saying, second step is search for block with only, with what? With only friction force. With force, only what? Friction. Now I'm asking students, Ballari students, if there are two blocks and if I'm applying a force over here, let me know which is that block which has only friction force. Is it M1 block or M2 block? M1 block or M2 block? Ballari students? Very good. So M2 block. Now take this M2 block. Take this M2 block. Okay. Now students, can I say, see, for this M2 block, there is what? There's a F limiting friction. Yes. Now, can I say that now the maximum force that will be applied will be F limiting for this M2. The maximum force for M2 will be what? What? F limiting. Yes or no, students? Let me know. Ballari students. ಬೇರೆ ಫೋರ್ಸ್ ಎಂತ ಇಲ್ಲಲ್ಲ. ಈಗ ಇಲ್ಲಿ ಒಂದು ಲಿಮಿಟಿಂಗ್ ಫೋರ್ಸ್ ಬಂದ್ರೆ that will be the maximum force, right? Yes or no? है कि नहीं? Yes or no? Ballari students? Others? Ballari students, I can't continue unless and until you tell me, okay? Now, here you know that this is what? The limiting what force. That is a case, then the acceleration is also limited, yes or no? Then the acceleration is limited. Or can I say this acceleration is basically what? The maximum acceleration that it will get. Yes? Yes or no? Yes or no? Now students, from this you get the maximum acceleration, A max. Okay, now you got some answer for that. Till now it is clear. Is it good? Yes. Now students, see, illi eradu case illi, just hear me out. See, over here you know that there will be acceleration of what? A1 is the acceleration of what? Mass m1. Now students, can I say if a1 equal to a max, if both acceleration are same, m2's and m1, basically this is m2's acceleration, then can I say if both are moving the same acceleration, then they will move together? Yes or no? How the? If that is the case, yes. YouTube students, let me know. Very good. Yes. If that is the case, another case, can I say that if a1 small, that niche wala jo hai, agar if its acceleration is less than a max or a2's acceleration, then also it will move together? Yes or no? Yes or no, students? Agar idra acceleration is less than this one, so it will say, if it is like moving with lesser acceleration, then it will move together. Yes or no? Yes. Very good. Now you got this a max. Now students, the next case would be what? Use this a max in the other block to find what? To find F max. And this will be a question. Don't worry students, in the next class we'll be solving the question. Aga complete clear ಆಗ್ತದೆ, okay? So whenever we solve problem, you'll be like, okay. Is it good, students? YouTube students, thank you for attending. If you have any doubt, let me know, okay? So we had problems to solve, but since the concept was not that clear, okay, so I had to repeat it. So I don't have poll, students. Okay, let me know in the chat how was the class. Let me know in the chat, okay, how was the class. And if you have any doubt, let me know. Okay, thank you for attending, students. Take care and what?